Okay, let's take a look at 42. We got y is equal to x squared minus 2x minus 8. And so for each equation given in 41 through 52, find the x and y intercept. Okay, our x-intercept. Let's start with that. Now for our x-intercept, how you find the x-intercept? You always plug 0 in for the other variable. So we'll plug 0 in for y. So we got 0 is equal to x squared minus 2x minus 8. And we want to factor this. This factors as x minus 4 times x plus 2. Now the zero factor property, if you get 0 on one side and you factor the other side, you set each factor equal to 0. So we'll set x minus 4 equal to 0 and x plus 2 is equal to 0, which gives us x equals 4 and x is equal to negative 2. I'm assuming the end goal is to graph it. Okay, so negative 4, 1, 2, 3, 4, and negative 2. That right there. Now our y-intercept. You always plug 0 in for the other variable, so we'll plug 0 in for x. So we got y is equal to 0 squared minus 2 times 0 minus 8. 0 squared drops away, negative 2 times 0 drops away, so that gives us negative 8. So our y-intercept is at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That right there. Follow procedure to create a table of sample points on a graph of the equation. Plot the sample points and create a rough sketch. I think what they're indicating here is you want to create a t-chart. Until you see the true picture of what the graph looks like. Now I want to choose an x value to plug in. Maybe I kind of got an idea here. Let's try 1. So you plug in x equals 1. You plug that in for the x here. So we're going to have y is equal to 1 squared minus 2 times 1 minus 8. 1 minus 2 is negative 1. Negative 8 is negative 9. So this point would be 1, negative 9. That's our t-chart. 1, negative 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, negative 9 would be more or less right there. Now let's plug in 2. So I'm going to have y is equal to 2 squared minus 2 times 2 minus 8. 2 squared is 4. 2 times 2 is 4. 4 minus 4 drops away, so that gives us negative 8. So this point would be 2, negative 8. So 2, negative 8. Now I'm kind of seeing the pattern here. That looks like my low point and looks like it's coming back up. I could plot some more if I wanted to. You can see the pattern. But the graph, if I roughly sketch it, as well as I can sketch, would look like that. Test for symmetry. If the equation appears to fail any of the symmetry, find a point on a graph whose reflection fails to be on a graph as was done at the end of example. Well, if I plug negative x in for x, this will test symmetry with regards to the y-axis. Now I can see from looking at it it's not symmetric to that, but let's just show it. So I'm going to go to my original problem, and I'll replace all my x's with parentheses. And if I plug negative x where the x was, then the question is if I can rewrite it such that it looks like the original problem. Well, negative x squared is positive. Negative x times negative x is positive x squared. Negative 2 times negative x is a positive 2x minus 8. It's close, but we got a plus here instead of a minus. So it's not symmetric to the y-axis. Now if I plug negative y in for y, This would tell us if it's symmetric to the x-axis. So if I were to plug negative y in for the y, we'd have this right here. And the question is if I could rewrite this such that it looks like my original problem. Well, I could divide everything by -1, but it would not look like the original problem. So the answer here is no to the x-axis. Now, you could plug, I'm running out of room, so I may not actually do this one, but you plug -x for x and -y for y. This will tell you whether it's symmetric to the origin, which it's obviously not looking at it. But if I have -y equals -x squared minus 2 times -x minus 8, -x squared, or -x to the second power is x squared plus 2x minus 8. Now I could divide everything by -1, in which case this would give me a y is equal to -x squared minus 2x plus 8. But there's no way I can get this looking like the original problem, so the answer is no there. I have no clue what they're saying here. Find a point on the graph whose reflection fails to be on the graph as done at the beginning. Oh, I suppose you just pick a point. So like if I chose, for example, 2, 1. I'm going to do a 2, 1. If I chose this point here is 4, 0. I'm understanding what they're saying now. For this to be symmetric to the y-axis, then I would have to have a point on my graph that was -4, 0. Now I don't. It doesn't go over that far. So that's what they mean by picking a point. And anyway, that's our graph.